Yes, test this week for work keys testing for anyone who didn't complete that already, because we did that a couple of months ago. This is the last opportunity. The state says all seniors need to take the work keys test, and most of you've got that done. But there's a few people that still need to come up here and complete that before graduation. So that is Wednesday, and you should have received emails from our principal, Miss Scott. So those of you who need to be here should know who you are by now. But, Thursday, I need to let you guys know. Thursday, there is a what did they call it? The job fair up here at BHS in the gym, and it's for all you guys. You can come up with resumes. Bring copies of your resume. Any information like that, if you have any kind of extra certifications or whatever. But we're going to have a job fair, and there's going to be lots of companies up here with booths set up, and you can talk to people that are looking to hire. You can get more information. You can leave resumes with them. Some of them may be actually having you fill out applications there at their booth. I don't know what they plan on doing. I just know there's going to be lots of companies up here that you can talk to if you're looking for a job or looking for a different job or looking for a second job or, whatever your situation is. Print some resumes out. Come up here Thursday. It's going to be from 9:30 to noon, I think. Let's see if I can confirm that. I'm going to be involved in it. I mean, I'll be there. So there'll be someone that you recognize there. I'll be mulling around with all the students just to give you a face that's familiar. But it'd be a good time to come just kind of network and get some practice in talking to employers, see what kind of questions they have, and all kinds of good stuff like that. Of course, it's optional. You don't have to come. But this is something that if you're needing a job or wanting a job or just find out information about what they're looking for in jobs. This just is a good opportunity for you to come up and have that. So instead of going out and having to contact 50 other companies, let them all come to you in one place. Be here by about it's 9:30 to 12. You will need your school student ID. Have your ID if you're coming up here to the school anytime you're on campus. But yeah, bring your ID. If you don't have an ID, you can come by the virtual office and pick up a temporary ID. But come up here, 9:30 to 12. Bring a copy of your resume. Any questions you have, bring a pencil or pen to where you can fill out information if they're taking information like that. But I'll be down there, and Miss Cruz will be down there. So Miss Cruz and I will both be down there. And if you come, we're also going to have a bingo card that you fill out. Like if you talk to these booths, you get they'll fill out your bingo card, sign your bingo card, and you can get, there's a drawing. There's prizes. There's prizes at the end. So you can be in a drawing if you get your bingo card filled out. So come on Thursday up to BHS up here. We've got this job fair set up. Lots of employers will be there with booths. You can come talk to all these employers. You can hand out resumes, all that you want to do. And it's certainly optional, but it's to your benefit anytime to talk to employers and find out what they're looking for and just build those skills of kind of interviewing or talking to business owners, just because it'll help you going forward. So, all right, that is what's going on this week. So work keys testing is tomorrow. Like I say, you should have emails. If you haven't taken the work keys test yet, you should have that email. And then Thursday, the job fair. So all kinds of exciting stuff. That must mean we're getting to the end of the year. Yes, we are, because May is Wednesday. May. So seniors this week, next week, finals on Monday and Tuesday after that, 13th, 14th, unless you're exempt. Graduation. Wow, graduation is what, 2 weeks from this Friday or Saturday, this Friday? Yeah, coming real quickly. All right, let's get our lessons. Let's take a look at what we're doing this week. I do have good news in that respect, because I said we were trying to pack all this in by the end of the year. We had 2 lessons last week, 2 this week, 2 next week. I've changed that. I have pared that down because with all this senior stuff going on and everything, we don't have time for all of that. So we're only going to do 1 lesson this week, and one lesson next week. Notice I've skipped 8.03. I had another lesson in there, had another lesson to go next week, but we are cutting it down. We're doing one lesson this week, one lesson next week. So if you're behind on anything, and I don't know that many of you are in here, if you're behind, it's not much. There's just a few. And I didn't look to see who all turned in this stuff that was due yesterday. But complex zeros, what we're going to look at today, 8.04. Next week, we'll do the fundamental theorem of algebra. And then seniors will be done. We'll have the final for anyone who's not exempt. And then anyone who's not a senior, we'll have something to do if you're not a senior for the next couple of weeks after that. But seniors just have 2 lessons left. So let's look at 8.04. Oh, let's close module 7. We're done with that. 8.04, complex zeros. All right. A difficulty that we've avoided in determining real zeros is that some quadratic equations don't have a zero, at least not one that's a real number, right? If the parabola doesn't touch the x-axis, there's no solutions. However, there are solutions. They're just imaginary. Like x squared plus 1 equals 0. That's a parabola, but the vertex is up 1 off of the x-axis. It's at 0, 1. So there's no real number that when we square it, because this would have to equal -1. -1 plus 1 would equal 0. There's not a number we can square to equal -1. That's where we got to the imaginary. The square root of -1 is I. It's not the first time you've heard that, but it's an imaginary number. So complex numbers, which is what we're looking at this week, are written like this: A plus BI, where A is the real number, right? A is a real number, an integer, or whatever kind of number. And the BI is the imaginary number, where if A equals 0 and B is not equal to 0, it could just be BI. Maybe you just have the I portion. You may not have an A plus, right? May just be like in this example up here, square root of -1 would be a 0. You wouldn't have a plus. You wouldn't have 2 plus a square root of -1. Just that. So we see that the set of real numbers and the set of imaginary numbers make up the set of complex numbers. So let's look at operations with complex numbers. If we have 2 different complex numbers, A plus BI and C plus DI, written in standard form, are equal to each other only if A and C are equal to each other and BI and DI are equal to each other. So let's look a little bit at adding and subtracting complex numbers. And we're going to do that on paper. So we're going to make up some problems to play with on complex numbers. So it said that it was trying to get a principle there that if A plus BI equals C plus DI, this is only true if A equals C and BI equals DI, which means the real numbers would have to be the same and the imaginary numbers would have to be the same. So let's play with some complex numbers. So if we have 3 plus, and we'll just say the square root of 2. And we want to add to it, this is a complex number, this is a complex number, -1 minus 3 square roots of 2. We're going to add these together. When you add those together, it's actually very, very simple. You just have to keep the real numbers real and keep the imaginary numbers, I'll underline those with a different color. You just have to keep those separate. We can't add these together. We can only add the real numbers together. So this would equal 3 plus -1, 2. And then we've got square root of 2 minus 3 square roots of 2. So it's minus 2 square roots of 2. So that is the square root of 2 plus -3 square roots of 2. So this would be the answer. And we kept the real numbers separate. 3 and -1 is 2. Square root of 2 and -3 square root of 2 is -2 square root of 2. Let's do another one. 7 plus 2 square roots of 5 plus 6 plus the square root of 5. 7 plus 6, 13. 2 square roots of 5 plus another square root of 5. Don't make it difficult. You can only add real numbers, and you can only add complex numbers. Oh, wait a minute. What am I doing? These aren't even complex numbers. I'm going to put an I at the end of it. I'm sorry. I. 3 square roots of 5, I. 2 square roots of 2, I. The I is what makes it imaginary. I forgot the I. And actually, we would actually want to write this minus 2I square roots of 2. And we'd want to write this 13 plus 3I square roots of 5. Now, don't be confused. It doesn't have to have a square root. We could add 2 plus I plus -4 plus 4I. These are complex numbers. These are easier to don't have the square roots in them. I is a square root. It's the square root of -1, right? But this would equal 2 plus -4, -2, I plus 4I plus 5I. Keep the real numbers together. Keep the imaginary numbers together. And subtracting works the same way. We can subtract just like we add. Got to have the I's in there. Man, I was leaving off the I's. So yeah, A plus BI minus C plus DI be A minus C, because that's the real numbers. And BI minus DI. B minus DI. So the properties, some of the properties for real numbers are also valid for complex numbers, like adding, subtracting, the commutative property, you distribute the same way, distribute property of multiplication. X plus 1, X minus 1 would be X squared minus 1. We can do the same thing with complex numbers. We can multiply and divide complex numbers. So let's look at multiplying. I'll use their example right here. 5 minus I times 6 plus 3I. Let's multiply those together. And it works the same as if it was not imaginary numbers. We just distribute, right? So we have to take this 5 and we have to multiply it by the first term, and we have to multiply it by the second term. 5 times 6, 30. 5 times 3I, 15I. Now we have to distribute the second term, right? So the negative I has to be multiplied times the first term. And this is a negative I. So negative I times 6 is negative 6I. Negative I times 3I is negative 3I squared. Oh, so now that means we need to stop and talk about something, which this is not totally brand new, but it's a good refresher. I equals the square root of -1. All right. What does I squared equal? Well, I squared would be the square root of -1 squared. What happens when you square a square root? They cancel each other out. If we take the square root and then we square it, those two things cancel each other out. So it's just -1. I squared equals -1. How about I to the third power? Well, that's -1 times the square root of I, which is the square root of -1. So it's negative square root of -1. Because it's just -1 times that. I to the fourth is this. That's the same thing as I squared times I squared, which is the same as -1 times -1, or +1. Because if this is I squared is -1, I squared is -1, -1 times -1 is a +1. So here's the 4 different cases you have. I, which is the square root of -1, I squared, which is -1, I to the third, negative square root of that, or negative I, and I to the fourth, which is a +1. All right. So that means this can simplify to -3 times -1, because I squared is -1. That's what this is, -3 times -1. So let's simplify it all. 30. We got 15I minus 6I. +9, because not 15 minus 6. And then -3 times -1 plus 3. So this simplifies to 33 plus 9I. Just 30 and 3 add together, but this is imaginary. We can't add that together. This is not 42I, because this has an imaginary portion. These are not imaginary, so we can't combine them. You cannot combine imaginary and real. So multiplying these together is 33 plus 9I. Let's see what they got. Check your answers. We did the third problem. 33 plus 9I, there it is. Fabulous. And then you can divide as well. All right, plotting complex numbers. So for the most part, we will not deal with complex numbers in applications like trying to apply it. But it'd be good to be able to plot it. But you need a complex plane to do that. Instead of an XY axis that uses real numbers, this uses a horizontal axis called the real axis and a vertical axis called the imaginary axis. All right, so for the complex number a plus bi, you plot a on the real axis and b on the imaginary axis. And that's the end of the lesson. Let's look at the more complex example they talk about here. Maybe they'll show us one of these graphs down here. So this is adding and subtracting. So they go into more detail, give you more examples. Multiplying, distributing out there, raising it to a power. Talking about the I squared and all that good stuff. Complex conjugates. Oh, they go into that. They didn't put that in the summary. We'll talk about that real quick. We'll talk about that. Let's see. Dividing. So dividing involves the complex conjugate. So that's why we need to talk about that real quick. Complex solutions of quadratic equations. Yeah, you could use that the quadratic formula, and that'll tell you if you have imaginary solutions, because you'll have that square root of a negative number underneath there. Okay, they don't show a graph. But we need to talk about complex conjugates and do a division example. If we have 4 plus 2i as a solution, all right, when we have a solution that's 4 plus 2i, and we found that with the quadratic formula, or however we found it, imaginary solutions come in pairs. You never have one imaginary solution. You always have two. And the second one will be its complex conjugate, which means if this is a solution, this will be the other solution. This is the complex conjugate. Notice the only difference is one's a positive, one's a negative. So if you did the quadratic equation and you come up with this solution, that means you'll also have this solution. And you're like, well, what about this? Well, this is the same thing. This is actually 0 minus 3i and 0 plus 3i. See, if I wrote it like this, these are the same thing as these are, except the real portion is a 0. So you have negative 3i and positive 3i as your two solutions. They always come in pairs. So let's talk about dividing. Let's go back to the example problem they have. Let's work the example division problem, because you're like, I don't know how to divide this. If we take 5 minus 2i and divide it by 7 minus I. Okay, this will be good. 5 minus 2i divided by 7 minus I. Well, we have to get rid of the fraction. Or get rid of the, down here. We multiply, when you divide complex numbers, you multiply by its conjugate. Like, whoa. Well, let's see what that looks like. 5 minus 2i times 7 plus I. 5 times 7 is 35. Minus 5 times I is 5i. Minus 2i times 7 is minus 14i. Minus 2i times I, minus 2i squared, which we know is minus 2 times minus 1. So that's plus 2. On bottom, we get 7 times 7 is 49. 7 times I is 7i. Negative I times 7, negative 7i. Negative I times I is negative I squared, which negative 1i squared. So that's going to be plus 1. So this simplifies to 35 plus 2 is 37, plus 5 minus 14 minus 9i, over 1 plus 49 is 50, and those cancel out. 7i and negative 7i. So this is our answer. This is what it ends up when we divide. Let's see what they got. 30, there it is. They also broke it out as two factors. 37 over 50 minus 9 over 50i, but 37 minus 9i over 50. See, the other way they did, they wrote it, they said you can write it like this, or you could break it out and say 37 over 50 minus 9 over 50i. These are the same thing. You can break out the 50 under each thing. But they run to write it like a complex number, 37/50ths, which cannot be simplified. Those 37 is a prime number. Minus 9/50ths. 3 divides into 9. 3 does not divide into 50. That can't be simplified. But you can leave it like this. It's perfectly fine. Leave it like this. It might be easier to understand. Maybe move the 50 over in the middle where we know it's underneath everything. But that's how you divide. You divide complex numbers by multiplying by its conjugate. Conjugate. And let's put that term on. Conjugate. And all you do is change the sign in the middle. If it's just a negative 3i, you just do a positive 3i because it's 0 minus and 0 plus. Conjugates. Okay, let's look at the assignment for this week because that's the whole lesson. Write the sum or difference in the standard form a plus bi. So it wants you to add 4 minus 2i plus 9 plus 6i. What's the answer? It wants you to multiply these. Which one of those is the answer? Find the product of the complex number and its conjugate. That's multiplying. It wants you to multiply this times its conjugate. They didn't give you its conjugate, but you should know its conjugate. If that's 1 plus 2i, If it's 1 plus 2i, we know the conjugate is 1 minus 2i. That's why they didn't give you the conjugate, because you need to know what the conjugate is. It's the exact same number with the sign changed. So multiply that by its conjugate and then simplify it. Write the expression in standard form. Oh, this just wants you to simplify that. Oh, I know. I want you to multiply. You gotta multiply it by its conjugate to simplify it. Multiply it by its conjugate, and that will simplify it because it'll get the I out of the denominator. And this is the simplest problem I'll give you all year. And here we are in the end of April. -4 plus yi equals x plus 3i. What numbers of x and y make this true? This is what it's asking. If one of these blanks is an x and one's a y, how can I make these equal to each other? What number does this have to be? What number has to go before the I for these to be exactly the same? Equal. You're not going to make that hard, are you? That's like saying something x plus 1 equals 2x plus something. Let's see. How can I make those equal? I guess this would have to be a 2 and that to be a 1. Oh, look, 2x plus 1 equals 2x plus 1. That couldn't get any simpler if I just covered up these numbers and say, what does it need to be? That's all this is doing. It's just using I. That's all it's doing. So, all right. So, yeah, all you have to do in here is say x equals whatever the x equals and y equals. That's all you're doing. See, we've really cut it down. I was going to do 2 lessons today. Here it is, 9:27. We're already done with our lesson. You've got 5 questions. This week ought to be really quick, which is great. So if you're missing anything from past weeks, you've got a great chance to get caught up on that this week because you've got a very short assignment. And we'll do 1 assignment next week. We're gonna cruise into the end of the year a little easier. So I backed off. Yeah, you're welcome. All right, guys. Any questions? Complex numbers, don't make them overly complicated. As long as you know that I squared equals -1, that'll help. All right, if you need any help, this Friday is a B day, so I will be here Wednesday if anyone needs any help with this assignment, or if you need help with a past assignment, I'll be here Wednesday. Otherwise, we'll see you next week for the final week for seniors. Have a great week. We'll see you guys.